So what are the operations we know, like the logic decision operations? Last week, in the last session itself, we saw two operations called OR and, correct? Let us represent this OR and operations. So I have two variables, X and Y, which are inputs, and Z is the output. So these are my inputs. This is my output. So each of this variable can take what? 0 or 1. So my X can take 0 or 1. My Y can also take 0 or 1. So if I look at basic possibilities, both of them can be 0. X can be 0, Y can be 1. X can be 1, Y can be 0. X can be 1, Y can be 1. These are the all possible combinations. No other possibility exists. 0, 0, 0, 1, 1, 0, 1, 1. Now what will be the output for OR? What did we see? What is the English meaning of the word OR? At least, correct? If I say either you do this or you do this, means what? You do both the actions or at least one of these actions you have to do, correct? So suppose, for example, even you write your exams, right? In that they say you answer question number 4 or answer question number 5. Means what? Either of one you should answer. If you answer both also, it's fine. But at least one among these two you should answer, correct? So means what? At least one among them should be 1 to make the output as 1. If both of them are not met, the output will be 0. Like you didn't answer question 4 also, you didn't answer question 5 also. Correct? I can represent this in a different way also. 0 means no, 1 means yes. So I can represent this as what? No, no, yes, no. I'm sorry. So it should be no, yes, yes, no, yes, yes. Correct? So you didn't answer question 4 also, you didn't answer question 5 also. So that you didn't answer at all. You didn't answer question 4, but you answered question 5. So you have met the criteria, correct? Yes. You answered 4, you didn't answer 5. You answered both of them. It's well and good. Correct? So this is how the relationship will look like. Correct? So symbolically, I will represent Z is equal to X or Y. This symbol is used for OR. Okay? In terms of a operation, in terms of a logic gate, it will be shown like this. A logic gate is a physical representation of this decision making block. So this is a binary operation. I don't know how to realize this binary operation. We will see this. How to realize this binary operation, I don't know. But let us assume that there is a way I can realize this binary operation. For sake of argument, let us now assume that you can somehow realize that. How that will look like, the symbol of that module will look like this. This is the symbol of a physical realization of a binary operation. Physical realization of a binary OR will be represented. This is a OR gate. This is what I call as a OR gate. Similarly, AND. Let us look at AND. X, Y, Z. So again, these are the possibilities. 1, 1, 0, 1, 1. Now AND means what? X should also be met and Y should also be met. Correct? That is what is the meaning of AND. Correct? So that means here it will be 0. Here also, see, here all the conditions should be met. So 0 and 1. So this is false and true. Means the answer will be false. So this will be 0. 1 and 0. It will be 0. 1 and 1 only will give you 1. So mathematically this will be represented like dot or the and. As per the Boolean operation, the or, this is the symbol. So this will be denoted like x plus y. Don't confuse this plus with the additional plus. This is the or. Okay, this is your or. Either I show it like this, or in terms of Boolean algebra, I will show it like plus. In case of and, I show it by an ampersand or I show it by a dot. In terms of a symbol, it will look like this. This is your and. Clear? Clear? See, it's something like, think about it. If in a different way, if I have to explain, you add these two. 0 plus 0 gives you 0. 0 plus 1 gives you 1. 1 plus 0 gives you 1. 1 plus 1, don't think about 2. 1 plus 1 is also, you have to represent it with only one variable. So 1 plus 1 definitely will give you 1. Actually 1 plus 1 is 2, but definitely it is more than 0. So you represent it as 1. So you can represent it only using two notations, either 0 or 1. So definitely 1 plus 1 will give you 1. So in that way, it is not exactly addition, but it looks like addition. That's why we use the plus symbol for or. It is not exactly addition, but it is very similar to addition, you can think of. Here I am using the dot. Dot generally we use for multiplication. This looks like a multiplication. If you see 0 multiplied by 0 gives you 0. 0 multiplied by 1 gives you 0. 1 multiplied by 0 gives you 0. 1 multiplied by 1 will give you 1. That is why we are using this dot operation. Correct? Similarly, let us look at for 3 inputs for sake of argument. If suppose I have W, X, Y as inputs, what will be my output? So how many possibilities will be there? There are 3 variables. Each can take 2 different values. So there will be 2 power 3 input possibilities. 2 possibilities for each of 3 inputs. It will give you 2 power 3 input possibilities. So these are the various possibilities you will see. Eight different possibilities. 2 power 3 is 8. It will give you 8 different possibilities. So now what will be the output? 0 plus 0 plus 0 will give you 0. 0 plus 0 will give you 0 plus 1 will give you 1. 0 plus 1 gives you 1 plus 0, 1. So if you calculate it that way, 1 plus 1 we already discussed. 1 plus 1 mathematically, if you literally look it as a plus, will give you 2. But we are looking at the answer being 0 or not. It is clearly 1 plus 1 is not 0. So we represent it as 1. Like this, if you represent, this will be the output of the OR gate. This is the output of the OR. If I look for the same input, if I look at the output in case of an AND, how it will look like? 0 multiplied by 0 multiplied by 0 will give you 0. Clearly, you can see in all these cases, at least one guy is 0. So 0, 0, 0, anything multiplied by finally by 0 will give you 0 only. Correct? Even if you multiply 100 numbers and 101th number you multiply it by 0, irrespective of what 100 numbers you multiplied, the answer is going to be 0. Correct? That way, I'm saying all of them will be 0. 1 multiplied by 1 will give you 1. Again multiplied by 1 will give you 1. So, this relationship is what I'm going to say it as Z equal to W and X and Y. This relationship is what I'm going to say it as W or X or Y. This is an and this is a OR. Okay? Similarly, there is a NOT operation also.